Hi students, I think you are fine. My name is Ishan Akbar, and today we are going to discuss civil engineering structures. First of all, we have to know what is meant by structure, what the structure is. So, its answer is a structure is a combination of two or more structural elements, two or more structural elements are structural members. Suppose we want to make a simple frame, then this frame B will be like this. These are supports at the end of. So these two structural members are known as columns, and this member is known as a beam. This is also a column. So we can say that this is column 1, this is column 2, and this is beam 1. So this combination of structural members is known as a structure. As these are columns, these are beams, so there are other members there are present which form a structure. First of all, we have a member, structural member, that is beam. Second member we have column. Third member we have slabs. On fourth number we have bracings. On fifth number we have trusses or roof trusses. On sixth number we have retaining walls. And on seventh number we have footings. So first of all, we have to know about the structures. How many structures? There are mainly two structures, or maybe three. First structure is known as frame structure. Second one is a simple masonry structure. Or these are known as wall bearing structures, because in such structures we do not construct any frame of columns or beams, but we only introduce walls made of masonry. These walls are made of masonry. In wall bearing structures or simple masonry structure. And at the third number we have structures like truss structures. So frame structures are mostly made of concrete or steel, or sometimes they are made of wood if they are low rise. And simple masonry structures, as we know, that they are constructed by using mortar for courses and bricks or blocks. And truss structures are mostly made of steel, but wood is also used somewhere, and corrugated sheets are also used for roofs. But we are not going to discuss at this step the structures in detail. But first of all, we will take a simple frame structure and we will discuss the members of that structure. At the first number, we have beams. First of all, we have to discuss beams, what the beams are. So simply, a beam is a horizontal member horizontal member which carries loads but transfer these loads from its upper structure to the where it shifts load. It shifts a load from upper structure to the supports. These supports may be columns, and most probably their columns are walls, anything. So first of all, we have to know about the loads, what the loads are. So there are different types of loads which can act on a structure. Loads. First of all, what is load? Suppose we have a beam like this. This is beam. How many types of loads can act on this beam? Suppose we have this point A, there is a load. This one is a load. Then this load may also act on this beam, this type of load. This type of load may also act on this structure or beam. This type of loads are also present, and this type of loading is also present. So one by one we will classify these loads. This one we will call it as load number 1. This is load number 2, 3, 4 and 5. At number 1 we have point load or concentrated load. At number 2, this one, from this point to this point, this load has uniform value, so this is known as uniformly distributed load, or it has other name of rectangular loading. At number 3, this load is increasing from 0 and goes to its maximum value. So this load is known as gradually varying load. The gradually varying load starts from 0 and reaches to its maximum value. This load is also known as triangular load. At number 4 we have this value. We can see in this figure, this is combination of a rectangular loading, and with this an additional triangular loading is also applied. So this is combination of rectangular loading and triangular loading. So we can say that this fourth one is trapezoidal load. And at fifth position we have this type of load. This is called moment load. These moment load may act in two directions. It may be clockwise or it may be anti-clockwise. Suppose at this point this loading is acting in this direction, then this is clockwise, and this, if this is acting in this direction, this is counterclockwise or anti-clockwise. For point load we have different directions of the point load. Suppose this is beam, a load is acting at this point. This is P. This is known as vertical downward load or vertically downward load. This is known as P or N. Different textbooks recommend different symbols for the point load. This load may act vertically downward, vertically upward, horizontally rightward, horizontally leftward, or it may be inclined in any quadrant. It may be inclined like this one in first quadrant, like this one in second, third and fourth. So this inclined load may act in different direction with different angles, theta, theta, theta and theta. We can resolve it into rectangular components, like this is a point load and making angle theta. Then we will have two rectangular components, this one and this one. We will resolve these components and this will give us two forces. One is vertical force and other is horizontal force. This rectangular load is shown in this figure 2. Gradually varying load is shown in figure 3, and trapezoidal load is shown in figure 4, and moment load is shown in figure 5. I have described all these loads according to their requirements. Thank you very much. See you in next video.